Hey guys, how everything going? Long time no see. There's outbreak of new, I don't know, coronavirus here. So everything's tend to be like stressful, and we are starting to work remotely from home. I hope this could be suppressed as soon as possible. Today, let's take a look at number 81, search in rotated or sorted array 2. We are supposed to have array sorted in ascending order and is rotated at some pivot unknown. And like this one, it will be, put the first three numbers, three, no. Oh wait, where is pivot? Here, first four numbers to the backward, and there's a new array here. And we're given a target to search. If found, we return true. If not, we return false. It's kind of the same as similar to there's a follow-up here. This is a follow-up problem to number problem we have solved before, which is number 33, where nums may contain duplicates. So before there's new duplicates, and now there's a new there might be duplicates. So we have to actually the solution must be similar to each other, So I'll just copy paste the code here and do some slight modification. If you want to know the details of number 33, please search on my channel. There will be a detailed explanation there. For this new one, let's just do a brief recap about our previous solution. So the array we received actually is something like these are two parts. The first k, 1 to k, the k plus 1 to n, which is in both of these subarrays, they are ascending. This is a constraint that S1 will be bigger than Sn in the previous problem because there would be no duplicates. But now it's different. It's bigger or equal to, right? Okay, so we're doing the same. We're using binary search. It's the basic structure will be the same. We pick the middle number, and compare if it's the same with the target. We return true. Currently, now we only return the true or false. So if it is smaller than it, for the middle, there will be two possibilities for middle, right? It's middle here, which is this one, or this one, right? So for this one, how can we judge this? In the previous solution, we judge this by comparing to S1, which is Si. But now we have different problems that it's actually there will be possibility of the S1 equals to Sn. Okay, so now for the first case, if number middle is bigger than it, equal than it, this is not good, right? If it is equal to it, we just return, right? Okay, so if nums middle is equal to nums I, we return false, right? So we can remove the equal here. So if it's bigger than it, then it must be here. Oh, sorry. Target is smaller than middle, and number middle is bigger than it here. Okay, so we can safely, if target is bigger. Wait a minute. Okay. So if case is this, and if target is bigger than it. Wait a minute. Oh God. There's some problem here. If target is smaller than the middle, and now if middle is the same as if it's same as Si, if it's same as Si, in middle, this is weird because we can surely say that if the number, if it's bigger than SI, it must be the case like this, right? So now, because now target is smaller than middle, if it's here, the target might be here or here. So we're now compare the target with SI again. If it's bigger than it, then the bigger than SI, then we say this is true, right? Else if target is smaller than it, then we say the target must be here. So we can surely move I to middle. That's true. And for the other case, we return true, right? If it's the same as SI, nums I. Okay. So for the other case, if nums middle is smaller than SI, if smaller than it, then it must be the case like this. Then there's only one possibility, that's target is here. So we move J to middle -1. This sounds fair. And for the other case, if it's the same as SI, this is weird because it's tricky. Let's say because SI might be equal to SN, if middle is the same as SI, we can it could be both, right? It could be both. Though this is hard. So the only thing we can know that because target is smaller than the middle, target is smaller than it. If S1 is in the middle, we can only know that S1 is not the target, right? Because let's say there is a 1 1 1 1 1 and 2 2 2 1 1 1. The middle is 1, right? But we can if you want to search 2, we find the 1, we don't know where it is. Because the 2 could be replaced to 1 as it doesn't change the middle, or change the I, or change the J. So the only thing we know is that if the middle is not the target, then the number same as it could not be the same. Could not be the target. So if for the other cases, what we do, we move I one step further. Okay, now for the case of target is bigger than it, we do the same. This is the same. This is the same. Okay, so if the middle is bigger than it, so if middle is bigger than it, we can do the same, right? If middle is bigger than it, then it must be the case like this. So for the big one, because it's bigger, there is only one chance that it's this. So this is true, but if it's smaller, the middle is smaller than, if nums middle is smaller than MSI, and the other case, then the middle is like this, right? And now if we say target is bigger than middle, it might be here or here. How we compare? We compare target with S1. If it's bigger than S1, then it should be here. If it's smaller, then it should be this one, right? So we come to now J. Why J? For J, I think I is. Should we use J? If we compare it to this one, well, sure, we use J. It doesn't matter, I think. Okay, if it's bigger than it, then this must be here. So we can move J to middle. Oh, this is true. So and now if target is smaller than MSJ, we I with model. Okay, so for the other cases, we return true. But for the one possibility that if the middle is the same as I, we don't know where it is. We do the same. We plus. We move the first one, right? The S1 could not be the case. So we at last, if you find nothing, we return false. I hope this could pass. Actually, I tried these problems for a few times, and oh, this. Oh, sorry. Hope it best. Hope it best. Hope it best. Ah, my bad. Hope it best. Hope it best. Hope it best. Okay, let's submit. Yeah, I just tried a few seconds ago. Oh god, the error. Return. Why I return true? Ah, god, this. I forget to change this. Yay! It is accepted. Good. So from this problem, I learned something that if we are going to search, we need to break the problem down into some subproblems. Like for this one, there might contain duplicates. So we can just remove this constraint and suppose that there's no duplicate numbers. And we can solve that by binary search easily, and then we can add slight modifications and solve it. Hope it helps. See you next time. Don't forget to follow my subscribe my channel, and yeah, have a nice day. Bye bye.